Hi everyone, welcome to Module 21. In the next few weeks, we'll be talking about modern development practices. Um, so, you guys have now gotten a good hold on the fundamentals of application development, right? So, you kind of know how, when modern applications are developed, how the front end works, how the back end works, and even a brief introduction to Android applications and iOS applications. What we'll be talking about in the next few weeks is what some common practices that you see in the industry today are, and we'll try to understand these common practices, why they're used, and it'll be a combination of me showing you some demonstrations, me asking you to read up on a few things, and analyzing the workflows behind how people implement certain modern techniques. So I'll go over a quick list of what we'll be covering in the next few weeks. We'll first look at version control with Git. A lot of you have already been using Git, but I'll go into a little more detail about what kind of things you can do with Git and why it's so powerful and why it's so important for you when you write code. We'll also look at backend architecture in the next few modules. We look at microservices. We look at different kinds of SaaS APIs and how to kind of build your application as a set of these APIs. We'll understand what an API gateway is, and we'll also briefly touch upon a new buzzword that's taken the industry by storm the last few years, and this is container technology. After that, we'll look at some popular application features and we'll try to understand how they actually work. So, for example, when you do login and authentication with most websites or most applications, you'll see that when you log in, there's an email verification step, right? It's not just using your username and password and signing in. Or you'll see that there's a mobile number, an OTP that's sent to your mobile number, and then you log in. Or sometimes you'll see that there's a login with Google, or login with Facebook, or login with Twitter. For example, the NPTEL application or the console that you guys used for development. This had a login with Google, right? So how did this work, and why is it different from doing username and password? We look at common patterns that people use for storing files on their backends, right? Some of you may have heard of Amazon S3 or AWS S3, which is a very, very common API that people use to store files. We'll then look at notifications. We'll then also look at e-commerce applications and see how payment gateways and payment wallets work. Then we'll cover certain popular micro frameworks that are used for backend development. For example, we look at the Express framework in Node.js, which we've already been using during the IMAD application, and the Flask framework in Python. We'll kind of understand what the design and the features of these micro frameworks are, and if you ever use a new micro framework, whatever language it is in, what kind of features you should expect from this micro framework. We'll also look at monolithic web frameworks, and these are larger web frameworks, and these are typically used to build applications in what is called the monolithic pattern, not the microservices pattern, which we're going to be discussing. So most of these frameworks use something called the MVC pattern to build applications, and we'll try to understand what that pattern is and what are the common features that you can expect out of frameworks like these, for example, Django or Rails. So that said, let's start with this particular module, and we'll be looking at version control. So version control is also called revision control or source code control, right? And this is to solve a very specific and a very important problem when you write code. Three examples of these problems, right? So if you're writing code and you're continuously modifying code, right? When you move from one working version of your application to another working version of your application, let's say you went from one stable version of the application to another stable version of the application, you edited some code, and you got a new version of the application, right? So how do you save multiple versions of the application? What if you want to go back to the previous version? Will you copy the entire folder, right? Will you have two copies of the folder, right? Is that what you would do? If you did that, then will you start taking copies every single day? But if you take copies every single day, that's not a stable checkpoint. That's just a copy at 11 p.m. every night or something like that. So this should be a little more systematic. Another example of a common problem is, how would you work on multiple features simultaneously? Let's say, for example, and I'll go into a more detailed example later on, but let's say, for example, you're adding a new feature to your application, but you're also fixing bugs on this application, right? So Now will you have two different folders, and in one folder you'll work on fixing the bug, and in another folder you'll work on adding the new feature, and once you're done you'll kind of copy paste individual files manually, right? This is also a problem. It's important for me to tell you, do not ever do that. Don't actually copy paste files from different versions or from different features into one file, right? That's not systematic at all. You'll notice that in most things to do with development, things are as automated as possible, right? So and there are tools for most of the kind of common problems that you can imagine, right? And version control is one of the most common problems ever since we started writing code. Another common problem is, what if multiple people wanted to work on the same code base, right? So what if I was working on some code and then I wanted your help, and so then I sent the code to you, and then you started modifying the code, and now how do I merge that with my code? Do I copy paste your file? If I copy paste the file, if I copy your file, what if I have also made changes to that file? Will my changes get overwritten? Will I start copying them line by line? So these are some examples of problems that are solved by good version control software. Now, Git has now become the standard for version control, and it is the most popular source code management system. Git was created by Linus Torvalds, who, as many of you would know, was also the creator of Linux, right? And Linus Torvalds has created a lot of software, but it's amazing that there are two pieces of software that he wrote that have completely almost changed the world, right? So he wrote Linux, and Linux changed the world, as you can see around you. And Git also changed the world, because every developer almost in the world now uses Git. That's not to say that there are not other version control systems. For example, there's Mercurial, there's Bazaar, there's CVS and SVN, which used to be really popular and still are quite popular in enterprise. But Git has kind of become the standard amongst most developers. Git is also what is called a distributed version control system, which is slightly different from the designs of older version control systems like SVN, which used to be centralized. We'll understand what this means in a bit. So let's jump in and let's kind of look at the common features of Git that you guys should have a good understanding of. So let's look at a few basics. So I'm going to create a source code repository. I'm going to commit files, right? I'm going to stage files and I'm going to commit them. I'm going to explain to you what committing means. Then we're going to kind of look at different commits. So even though I've made a new change, I'm going to go back to a previous change and take a look at it. And then we're going to look at a few common commands like status, diff, and log, right? So let's get started. So I'm in a particular folder, and I'm currently in this folder called imad/content/git, right? Now inside this folder, I'm going to create a new folder called my app, right? And I'm going to create a folder called app.js. So I'm going to write code in Node.js, and here I write console.log hello world, right? Let me just test this code. All right, cool. So my code is working. It's printing out hello world, right? Now I want to put this inside version control. So I want to track changes to these. I want to track changes to this file in the future, right? So if I make a change next, I want that to be tracked. So I'm going to initialize a Git repository. So a Git repository can be initialized by running the command git init, and you're on what is called the master branch, right? So if I do git status, it will tell me that there are untracked files. There are files that are not being tracked by Git, and that file is app.js. And it says nothing added to commit, but untracked files present. Use git add to track these files. So let me hit git add app.js, and then let me commit it. So I'll run a git commit. As soon as I entered a git commit, it opened up a text editor for me. My text editor is set to Vim. So I'm going to write a message, and I'm going to say adds app.js tested, right? So I've tested this, and so this is my first checkpoint, right? So if I do a git log, let me clear my screen. If I run a git log, I can see that there's a commit that I've made, and this is some information about me, and this is the commit message that I have, right? Now let's make another change to my file. So I'll say I'm writing a function called something, and that function just does a print and it says I'm something, right? And let me now call this function, right? So you can see that little star has appeared. This is just a tool that I have. This might not appear in your terminals if you have not set this up. So, but you can always find out what's happening by hitting git status. So when I type git status, it tells me that there are changes that have been made that have not been staged for commit yet. So there are changes. So it says that a particular file has been modified, and this file is called app.js. So in fact, I can do a git diff app.js, and that way I can see what has changed and what has been modified in app.js from the previous commit that I have. So when I do a git diff, I can see that a certain line has been removed. So a console.log line has been removed from the first line, and instead of that, 4 lines have been added that say function something and some code here. Then my console.log line has been added again, and then there's a something line that's been added again. So now I can add this file, and after I add it, I can commit it. So when I add a file, it's called staging the file. So I'm staging this file for commit, and now I'm going to commit this file. So I do git commit, and I put in a message saying adds a new function, right? Cool. So now I have 2 commits added. If I do a git log, you'll see that there are 2 commits, right? So these represent a commit kind of represents a checkpoint, right? So whenever I reach a stable checkpoint in my code, I should commit my code, right? That way I can kind of see what my different commits are. If your code is unstable, so for example, if I've written code but I've not tested it and it's not working, ideally I shouldn't commit it, because the idea is that when your code evolves over a long period of time, commits should represent stable or kind of stable checkpoints of your code. That said, you sometimes might need to commit source code that is unstable so that you can share it with other developers or other such use cases. So what I'm going to do now is that the way that git log is kind of printed is not particularly nice looking. So I'm going to change my git log command and use this git log command, right? So you can kind of copy paste this. So I'm going to copy this, right? And I'm going to head back to my terminal, and I'm going to run this git log command. So you notice that when I run this git log command, right, when I add some extra parameters to it and format it nicely, I get a better formatted looking message, right? So I don't have to see the entire commit hash. I see a smaller commit ID, and then I can see when this was printed in kind of a relative timestamp, right? So I don't have to look at 432 and 430 here. And I also see that I'm on a branch called master, and head means that this is where I am currently. So head is that currently my file system, or currently the files that are there when I do an ls are kind of represented by where head is, right? So for example, now what I can do is, if let's say for example I want to go back to the previous version of the file, right? So right now if I cat this file, I'm on the new version of this file. I want to go back to the older version of the file. So I can do a git checkout, and I can move to this older commit, right? And if I move to this older commit, you'll see a message saying that I'm a detached head state. You can ignore this warning. You can kind of ignore this setting for now. Don't worry about it, right? But if I now print out app.js, you'll see that this is the original version of the file, right? And if I want to go back to the previous version, right, I'm just going to run the git log command again, right? So you notice that head is shifted, right? If you look at the previous log, you will see that head is on the latest commit, right? And now head is on the previous commit. So that's because head represents the current state of my file system, right? So if I want to go back to kind of where I was, the new version of this file, the new version of my entire source code repository, I can do a git checkout master, right? So now I'm back, and you can see I'm back. I have my entire repository reset to what I have as master. So git is kind of changing the files for me as I execute various git commands, right? And so your question might be, hold on, what's happening? Where is git actually storing these various versions of the files, right? Where is all this data being stored? Obviously, Git must be storing this data somewhere. How can Git magically, when I click on master, when I say Git checkout, this commit ID AB1, how does it automatically take me back to a previous version of the code? Like, where is that data being stored? Is there some kind of a database where this is being pushed, or what is happening? So if I actually do an ls minus a, that is to show me hidden files inside my current directory, I'll see that there's a folder called .git. If I go inside the .git folder, right, I'll see where all the objects are stored, right? So this is kind of where all the different objects are getting stored. It's kind of like the internal database that Git has, where all of these objects at various different versions are being stored, right? So this should kind of show you what you can do with Git, right? So I can see my different versions, my different commits, and I can move between different commits. Whenever I make a change, I can do a git diff to kind of see what the different changes are. Another, for example, useful thing that you can do is without checking out, without moving to a previous version, I might want to just print out an older version of the file. So and this is just a random command that I'm going to show you. There are hundreds of commands that Git has with various different configurations. So I'll do a git lstree. So a git lstree will list out the directory of a particular commit. So if I do git lstree master, it will list out all the objects that are present in the current tree, which tree is kind of analogous to a directory. So in the current directory, it will list out all the objects that Git is currently tracking, right? So for example, if I had a new file called new.js, right, and I type something like random, right, it's not going to work. But if I do a git lstree master, you'll see that new.js is not there, right, because Git is not tracking that, right? What I can also do is I can also do git lstree, and I can provide the previous commit ID. So let's look at what the previous commit ID was. It was AB1. So now I can do git lstree. So now that lists out all the objects that were present on that particular commit or that particular version of my entire source code repository, right? And this was the file that was present. What I can actually, you'll notice that the hash of this file, right, the object ID here and the object ID here is different, right? So it's interesting to note that the way Git actually manages, different files and knows how certain files have changed is by performing a hash on the contents of that file, right? So it hashes the contents of that file. It does something called a SHA-1 hash, and then it uses that hash to figure out whether the file is changed or not. So you can see that the SHA-1 hash of this of app.js in master and app.js in AB1FED is different, right? In fact, I can print out this version of the file. So I can do git cat file, right? And you'll see that it actually prints out the older version or prints out this particular object, right? So it printed out this particular version of app.js. So these were some basic operations that I performed with Git. Now let's move on to using what is called a Git remote. So for example, the use case that we're kind of looking at now is that I'm done with versioning and I'm able to version the source code that is there on my computer. But now I want to upload this to to a remote repository, and there might be 2 or 3 different reasons for doing that, but the 2 most common reasons are that one, it's a backup of whatever you were doing on your computer, right? So you can back up the entire repository and or you can back up a portion of the repository and store it in a remote. And the advantage of doing that is that suppose something happens to your computer, you can recover the entire source code, and not just the source code but the entire history of how that source code is evolved from the remote, right? The other advantage is that people can clone from a repository. So so other developers can also clone from this remote or can also use this remote to kind of share the source code. Now it's interesting to understand that Git doesn't need to be central, right? There does not need to be a notion of a central remote where we'll be storing our changes and where other people will be, or including myself, will be cloning those changes or will be copying those changes, right? It doesn't have to be like that. A remote could also be on anybody else's computer, right? So a remote could be on a computer that is on my LAN. It could even be on my computer in a different folder. It could be anywhere, right? So I can. So this is why Git is called decentralized. I have a repository and you have a repository. I can treat your repository as a remote of my repository. So that means that I can kind of push the changes of my repository into your repository, and I can pull changes from your repository into my repository, right? One common way of setting up a remote, because I don't have access to your computer, is to set it up on a service like GitHub, right? So GitHub is just one of several services that are available, several free services that are available. So there's GitHub.com, there's Bitbucket, and what these services allow you to do is that these services allow you to create remote repositories, and you can kind of upload your code to these remote repositories. So let's quickly try this out. Let's head to GitHub.com. So I'm going to head to github.com and my user ID, which is Coco98. So let's create a new repository. So I go to this and I say new repository, and I say imad-git-experiments. All right. I'm going to create a public repository and I click on create. So now a repository has been created, not on my machine, but on github.com servers, right? And there are several options for what to do next. It says that I can create a new repository on the command line and then push that. Or if I already have an existing repository, then I can just push the changes and the data from my repository into this GitHub repository. So the way you do that is by adding a remote. So let's copy this and let's add a remote. As soon as I do that, I can list out all the possible remotes. I can do git remote, or I can do git remote -v. That will list out the remote. So it says that there's a remote called origin, and origin has, and this is the kind of URL to the Git repository that is there at origin, right? Okay, so now I can push my code. So I'm going to push to origin, and I'm going to push a branch called master. Don't worry about what a branch means. We'll cover that next. But I can push to this repository and I can push master. So as soon as I do a git push, it says that a new branch has been created on the remote repository, which is good. Once I refresh this page, you'll see that the source code has kind of come up on GitHub, right? And you'll see that there are 2 commits. So GitHub gives you a kind of, so GitHub gives me a nice UI to look at the different commits that I had. The same thing, very similar to what a git log would do, right? Okay, cool. So this is nice because now I kind of have a copy of my source code and my changes that I've been making to my source code on the Git repository. What I can also do is I can also clone this repository again, right? So if I click on clone, I copy the URL, and let me go to a different directory. So zoom this up. All right. So I can just do git clone, and I can enter that URL. And now as soon as I do a git clone, and I do an ls, you'll see that another folder has come called imad-git-experiments, and this is a copy of my source code, right? So that's kind of the example. And if I do a git log, right, you'll see that there are 2 commits that are there. So not only has the source code been copied, but also the changes that I had to the source code have been copied. So I'm going to delete this repository now. Cool. So this is kind of how remote repositories work, right? And this is again a very basic introduction. There's a lot more that you can do, which I'm not going to cover. And there's a lot more that you can do. One of the important things that I'd like to cover is that GitHub is very different from Git, right? So Git is an open source software that can run on any computer. I mean, any computer that runs Linux or Windows or Mac or whatever, and allows different repositories on different computers to kind of synchronize with each other, right? GitHub.com is a service. It's a proprietary service that's provided by the GitHub organization, which allows you to host and allows you to create GitHub repositories that are hosted on their servers, right? And they are doing this for the 2 main reasons of kind of backing up your code and for sharing your code with other people and collaborating. So which is why you would notice that when you created your first version of the application on the IMAD console, you signed in with GitHub. And when you signed in with GitHub, it actually forked a repository that was already there that we had created, and it forked that repository, or kind of copied that repository, and created a new repository for you on your own username, right? Called imad-app, and those are the kind of features that GitHub gives you. So so the both are very different. And again, just to repeat, just like GitHub, there are other software. There are other service providers also. Bitbucket and GitLab are the two notable ones that I've also used. Another question that you might have is, how, when I created a repository and I pushed and I pulled, can anybody start making changes to my repository, right? Can anybody read from my repository, right? How is the authentication kind of happening, right? When I do a git push and I'm changing the contents of my repository, how did GitHub know that the changes that are coming in, that Git is trying to push to this remote, are safe? So the way this works is that the git push URL, right? So for example, the git remote URL, right? This particular repository, the git that is running here, accepts certain methods of authentication, right? So there is an HTTPS method of authentication, which is what GitHub uses. So for some of you, when you do a git push, it might ask you for your GitHub password, right? You might have to type in your password every time you do a git push. And another kind of authentication is based on SSH keys, right? So everybody has a public-private key pair, and if you take the public key that is on your computer, for example, my public key is present here, right? I can take this public key and I can upload it to GitHub. So for example, if I head to my settings and if I head to my SSH keys, I have my SSH key uploaded here. Because I have my SSH key uploaded here, whenever I do a push or I pull, I don't have to re-authenticate myself with GitHub, right? So this is what allows me to this is how GitHub knows that I am actually me who's pushing those changes. And of course, the reason this works is because whenever you generate your SSH keys, the probability that SSH key is the same as my SSH key is almost impossible. Now, we covered two of the use cases, right? So we covered the use case of how I do version control. We covered the use case of how I can share my changes with other people. The third use case that we wanted to look at was a more complicated use case that is very common in teams, or that is very common when you have an application that you've actually deployed in production, right? So let's say you've taken an application and you've put it on a bunch of servers, or maybe you've given that application to your users and your users are using this application. So there's a stable version of your application that users are using. Now, of course, like with any other software, there are bugs in the software, right? And when users report these bugs, you keep updating your code and you give them updates. Or, if it's a website or an application, you keep updating that code and you keep redeploying the backend code, or you keep redeploying your Android code or iOS code, whatever it is. And that is kind of how updates to your code get made. So if you look at from left to right, let's say that this is the kind of version of my code as it's evolving, and I reached a V1 and I reached a version 1 of my application. Now, when there was a bug fix reported, I fixed the bug and I called it bug fix 1, and then I called it bug fix 2. So all of these changes are happening on a branch called master, right? So these are a continuous series of incremental changes that are happening. But imagine that before my users reported this bug fix, I had already started working on a new feature, right? I'd already started working on a new feature. So, and that new feature's development is something that might take time. Let's say, for example, it takes a few weeks to implement, right? So I'm implementing this new feature. Now, when I fix this bug, I can't share these half-baked changes with my users, right? I can only share the fixed version of the code. I can't share the new feature that I'm kind of still developing. And so how do we manage the fact that, we have branches in our code? That means that our code base is going in kind of two different directions at the current moment, and they might come back and they might merge later on, but as of this moment, they're two different directions, right? So one is my master kind of branch where, updates are continuously happening for my users, and another branch is where I'm doing, where I'm working on a new feature. So let's see how Git helps us with that. I'm going to head back to my terminal, right? So let's say, for example, I started working on a new function, right? And let's call this function big new feature, right? So I'll say console.log writing a lot of code, right? So I'm writing a lot of code here. Maybe I'm writing hundreds of thousands of lines, or there's a different module that I'm including. There might be a lot of stuff happening, right? Let's just also call this function here, right? And this is kind of just me doing some mock development. So I'm writing some code, I'm testing it out, and I wrote some more code. So let's say let's say I'm halfway done with this new feature now, right? So I do this and I'm halfway done with this new feature. So and now and me being halfway done with this new feature is kind of a stable checkpoint that I have reached for my application. It's not a stable checkpoint that I want to share with my users. It's not a stable checkpoint that I want to deploy, but it is a stable checkpoint. So I want to commit this code. The problem is that if I commit this code, right? If I commit this code as it is, what if there are bugs that I need to fix from the previous kind of committed version of my application? So instead of committing the code as it is right now, what I can instead do is create what is called a new branch. So I'll do a git checkout -b new feature, right? And now I can do a git add app.js and do a git commit and say halfway done with new feature, right? Tested so far so good. All right, that's not a very good commit message, but there it is. So now if I do a git log, and what I'm going to do is I'm going to use the large git log command that I had, right? So now if I run that git log, let's kind of try to read this git log message, right? So it's saying that my original commit was adding app.js. Then I had another commit called adding a new function. Because I had pushed that to origin, I can see that origin/master and master. So the the repository that is there on GitHub, that repository's master branch and my master branch are both at the same commit. But the head, right, which represents my current state of the file system, is not actually on master. It's on a branch called new feature, right? So now what I can do is I can do a git checkout master. As soon as I do this, if I look at my app.js file, this represents the older state of my app.js file. This is the new function is kind of not there, right? And if I do a git checkout new feature, right, and I look at app.js, I'll see that my function is there, right? So now, for example, what I can do is, let's say there was a bug fix on my master branch. I can go to app.js and I can say bug fixed, right? So let's say there was a bug fix in the function called something. So I fixed this bug, right? And now I can do a commit here. I can add this, and then I can commit this, and I can say bug fixed in something, right? And I can even push this so that the bug fix is available to other people, or the bug fix is kind of saved on the GitHub repository that I have. Now, if we do a git log again, right, you'll notice that git log, because of this kind of minus graph command that I've passed, it shows you a little kind of graph about what is happening. So it's saying that linearly what was happening was that there was AB1, there was 737. Work was happening here, and again linearly the next change that happened was 1772, which is where my current file system is, and because I pushed that change, which is also where the GitHub copy of my repository is, right? But at 737, another branch came out, which was D9F8, right, which represented some different changes that have happened. So the file 1772 and so the state of the repository 1772 and D9F8 have nothing to do with each other, but they share and they originated from the same common commit, but they are now in two different branches, right? So what I'm kind of trying to show you is graphically, let's say this is where my new feature is and this is where I've made a bug fix, right? So they're on two different branches. They both come from the same commit, right? So now what I can do is, let's say I go back to new feature and I continue work on app.js, and I'm actually finally completely done with this new feature, right? I'm done with development. I'm just going to test this out. All right, everything works. Let's do git add, let's do git commit, new feature completed, right? And in fact, I can share this work with other people, so I can do git push origin new feature. So now this particular branch will be available to other people also. So you can see git push origin new feature. So if I go back to GitHub and I refresh this, you'll see that there are two branches, right? So you can click on two branches and you can see that there are two branches, right? So there's a new feature branch and there's a master branch. I can even go to the commit history, and on master I can see that there are 3 commits, and if I change it to the new feature branch, the new feature branch also has the new feature branch has 4 commits, right? The first 2 are common and then these 2 are different, right? Again, just to make this clear, let me show you the log. So what you can see now is that there were 2 changes that were made to this particular version of the branch. There was D98, there was D9, and there's 202, and that's on the new feature branch. And then you can see that this star corresponds to 1772, which was just the single change that was made in the master branch, right? What I can do now is, I'm ready, I'm done with my work. I would like to now merge this code, right, with master. So the first thing that I will do is I'll do a git checkout to master. This is a typical workflow that happens. So I do a git checkout to master. I make sure that I pull the master branch, because let's say the master branch is the main version of our application that maybe other people are also collaborating on. And I pull that version of the master. So I do git pull origin master. That way all the changes in my master are up to date. So it says already up to date. I then check out to new feature, right? And I merge the master branch with my new feature branch, right? So I've merged these changes. So now if I look at app.js, you'll see that all my code is here, but you'll also see that the something function has been merged and the bug fix has now been merged into my code. So Git is fairly intelligent that way, or Git does expected things that way, right? So if Git sees that 2 files have been modified in independent portions, that file gets merged. But now I've merged this. So now I'm going to test this out again, right? Good. So the bug is also been fixed, and I've written a lot of code, and this feature has also been implemented. So let's do a quick git log and let's see what's happening. So you can see that these 2 branches have kind of merged, right? And this is where the new feature branch now is, and it says that the commit is that the master branch has been merged into new feature. Now what I can do is I can check out again into master, and I can in fact merge new feature back into master, right? So this way if everybody was collaborating on the master branch now has the new feature, the master branch has a bug fix. The reason why I merged master first into new feature was because in case there were any conflicts, right, in case I had made some changes that were conflicting with the bug fix change that had been made on master, because I merged master into the new feature branch, I would have to resolve those conflicts. So this might get a little complicated for you, but read up on some of the links that I've given on the slides, and this will help you explain some of these merge workflows, right? So after I merged into the new feature branch, I ensured that there were no conflicts. I merged into the new feature branch. I tested everything on my new feature branch. Now my new feature branch is absolutely up to date. My new feature branch now contains the bug fix, and it contains the new feature that I implemented. Once I've tested everything, I go back to master and I merge new feature into master. Essentially, they're both the same branch. Essentially, they're both pointing at the same commit now, right? I did not create a new commit. So if you look at the git log, it's actually quite helpful. Let's look at the previous git log, right? The previous git log said that there was new feature which said that the master branch had been merged, and this was commit ID 073. As soon as I did a git merge of the new feature, I did a git merge new feature into master. You can see that master, right? The master branch also now points to the same commit, right? So they're now both pointing to the same commit. And now when I do a git push origin master, the master branch which is there on GitHub will also point to the same commit, which is 073, right? So let's quickly go to GitHub. and let's refresh this page. Let's head to the master branch, right? And you'll see that it's pointing to 073, right? So that represents kind of me creating a new feature, me fixing a bug, and then merging those changes safely, right? So this was an example of how you would do branching with Git. I encourage you to go read up a little bit about what are the different kinds of merges that you can do and what are the different kinds of workflows you can have around merging. And as you guys start working in a team, this will be one of the most important features that you guys use. So again, to stress on the decentralized portion of Git, right? The way I can use Git is that if you are a developer and my SSH public key is kind of saved in your computer, then I will be able to push to a Git repository directly to your computer, right? All I need is an IP to your computer, and I can do a Git push, an IP and a folder path to your Git repository, and I can push to your repository, and I can pull from your repository. So one way that you can collaborate with another developer when you're using Git is that you can push and pull directly between these two repositories, right? But because this is hard, because I don't have your IP, or your IP frequently changes when you're on a different network, your IP changes, I can't access your computer directly. So then what we do is that we decide to create a central repository, and we put this typically on a service like github.com or Bitbucket or GitLab. And now what we do is we all push and pull against this central repository. And most of these services will offer a convenient way of managing access control via the UI. For example, the GitHub repository that I just created, right? This is a public GitHub repository. That means that anybody can go and clone this. So you can also now go and you can kind of copy this URL and do a git clone, and you'll get access to the source code that I have. However, you will not be able to push your code, right? That's because if I go to settings and I go to collaborators, you'll see that no collaborators have been added yet, right? So that means that nobody else except for me can actually push to this. So if I add your username, then you'll also be able to push to this repository. So that's the kind of UI facility that github.com or most typical services will give you, right? Next, I would encourage you guys to try out a lot more commands with Git to see what's possible, what's not possible. I'm sure you guys will have a lot of questions. Please do ask these questions on the forum, and then we'll do our best to answer them and to encourage a discussion. Try out these two tutorials, one from Atlassian. Atlassian is the company that manages Bitbucket, and one from GitHub. GitHub is the company that manages github.com. And try these tutorials out, and these will be a very good introduction into kind of more advanced commands with Git to understand how Git works. So to wrap up this particular module, I'd like to say that number one, always use Git. Do not copy paste files. Do not maintain versions of your files. Do not share files over email, right? So for example, if your friend is asking you for the source code, upload it to GitHub, add your friend to the GitHub repository. If you want a private repository, you can use a service like GitLab or Bitbucket, where you can create unlimited free private repositories. So create a private repository and then share the code. Don't email the code back and forth. Don't send screenshots of your code, and don't do stuff like that. It's always better to use a systematic tool. It's always better to use a systematic workflow and to start using tools, that will be a very big part of your life as a developer as you go forward.